Hello, and welcome to this video on crosstabulations, or crosstabs for short. We'll be working with two data sets. The first is the AdHealth data set for the course. And so let's begin by asking a research question. And so AdHealth has a lot of different variables, so let's begin by picking some course-related and specifically crime-related. This data set asks about status and experiences, such as victimization and crime commission variables. So let's ask, is there a relationship between being in a gang and marijuana use? So that's the research question. So we can generate a hypothesis from that research question. And let's generate a two-tailed hypothesis, which simply suggests there's a relationship between two variables. So in our research question, we're looking at gang membership and marijuana use. And so our hypothesis, let's propose, again, a two-tailed hypothesis, which says gang membership is related to marijuana use. And let's just leave it at that. In the AdHealth dataset, there are these two variables for gang membership and marijuana use. And both of those appear in wave 2. So that means they're in the second half of the dataset. So if I expand my labels, I'll be able to see what the variable names actually represent. And so for this example, both of these are going to be far down towards the bottom. And we're looking at section 27, question 44. If you tried marijuana since month of last interview. So since month of last interview, have you tried marijuana? And the answer choices here are no, yes, and then there's refuse, legitimate, skip, and don't know. And we see 6, 7, and 8 are coded as missing. So this is legitimate, skip, refused, and don't know. So that's the marijuana variable. And then the gang variable is going to be section 28, question 14. Have you been initiated into a named gang? And the answers are no, yes, refuse, legitimate, skip, don't know, not applicable. So 6, 7, 8, 9. So we see 6, 7, 8 are coded as missing. Okay, so to generate a crosstabs to test our hypothesis, so gang membership is related to marijuana use. So let's go to Analyze. Drop down menu, go to Descriptive Statistics, and from that pop-out menu on the right, choose crosstabs. When you're setting up a crosstabs, it's important that you see how the independent variable is distributed across the levels of the dependent variable. So to keep it consistent throughout this course so that we're all on the same page, let's put our independent variable in the rows and our dependent variable in the columns. So in this instance, we're looking at, does gang membership, in this example, the hypothesis is gang membership is related to marijuana use. So we're examining gang membership as our independent variable and marijuana use is our dependent variable. So gang membership will go in our rows. So let's scroll down to 27, 44. Also, that's marijuana use, sorry. So marijuana use is our dependent variable, so we're going to put that in our column. And we're also going to look for gang membership, and that's in section 28, question 14. Initiated into a named gang. So I choose that, and I select it into my rows. Now, it's important to, when you compare things, because the number of people that were initiated into a gang versus the number of people that were not initiated into a gang is different. The number of people that were not initiated is going to be vastly different. So we don't want to compare actual numerical values. That's not a fair comparison. We're checking to see how the distribution of the independent variable differs or varies or changes across different levels of the dependent variable. So we want to compare percentages. So we want to compare the percentages of the independent variable, which is along the row. So we really only want to look at row percentages. And we'll keep observed counts checked just because it's the default option here. So after that's checked, just click continue and then click OK. SPSS generates the output, and there are two boxes. The first box just tells you how many cases were processed. 4789, 45 are missing, so a total of 38 were analyzed. So what we're looking for here is the percentages. So notice in the row percentages that 76.4 plus 23.6 gives you 100%. So this is what we're comparing in a cross tabulation, the row percentages of the independent variable. So if you look at the table, notice that there is a true diagonal here. The high percentage for the no category, for the initiated into a gang, so I was not initiated into a gang, the high percentage is no. I have not tried marijuana since the month of the last interview. And notice for the people that were initiated into a gang, so that second row, or the yes answer, their highest percentage is, since month of last interviewed, I've tried marijuana, their high percentage there is yes. So there's a true diagonal there. And notice that the low percentages are also on the diagonal. So for those people that were not initiated into a gang, only 23.6% did try marijuana since the last month of interview. And for the people that were initiated into a gang, only 37.7% did not try marijuana. So the lows and the highs are on a diagonal here. So that is a good indicator that there is a relationship between being in a gang and trying marijuana. So if we had to give some sort of initial support for a hypothesis, we would say gang membership is related to marijuana use based on the descriptive statistics presented in this cross tabulation. However, when we analyze data in a cross tabulation, in this instance we're dealing with a 2x2 table, so it's clear to see if a diagonal even exists or not. But sometimes we deal with cross tabulations that are not in a square or a 2x2. Sometimes they're 3x2s or 4x3s, and so that it's difficult to judge whether a diagonal even exists or not. So let's look at a different variable, and let's switch our data sets here. So we're going to switch from the ad health data set to the white collar crime data set. When you launch the white collar crime data set, you're dealing with a lot fewer cases and a lot fewer variables, so it's easier to kind of wade through. So let's start by asking ourselves a research question and then proposing a hypothesis. This time we'll propose a one-tailed hypothesis. So our research question here, let's ask, is there a relationship between being a victim of crime and fear of crime? So if I try to find these variables here listed in SPSS dataset, I can find victim of crime, and so we see at row 16. Expand my label column, and if I click in the label column, I just kind of expand just a bit. You can see in row 16, were you a victim of crime in the past year? And our answer choices are no or yes. So we're comparing were you a crime victim during the past year and their level of fear. And we have different fear variables or worry variables, and so we need to be specific about the one we're going to use for this analysis. And there's a good one for cross tabulations here called Worry X. This is fear of crime 3 category. So when you look at the options, there's 3: low, medium, and high. And so are crime victims different in how much fear they have than non-crime victims? And so let's propose a one-tailed relationship and say being a victim of crime will lead someone to be more fearful So that's a specific direction. We're saying being a victim of crime leads you to have more fear as opposed to less fear. So let me close this dialog box. So I'm going to set up another cross tabulation. So I'm going to go to Analyze, choose Descriptors from the drop-down menu, and from the pop-out menu to the right, choose Crosstabs. And I'm going to put my independent variable as the row and my dependent variable as the column. So I'm going to choose if I can find it. Were you a victim of crime in the past year? So that's going to be my row, and my column will be fear of crime 3 category, which is the worry X. So I move that to my column. Again, I go to the cells button and I see that I want the percentages for the independent variable across the different categories of the dependent variable. So I'm going to choose row percentages, click continue, then click OK. When the output appears, I see the same two boxes as the previous analysis. One telling me how many cases were analyzed, and then the actual results of the cross tabulation. So we have 2 values for our independent variable, no and yes. Were you a crime victim? So for people who were not crime victims, 64% are in the low, 26, almost 27% are in the medium, and 9% are in the high. For people who were a victim of crime in the past year, their fear levels are different. They're 41.5% in the low, 38.3% in the medium, and 20.2% in the high. So there is no clear diagonal here. In fact, when you carefully analyze what's going on here, the most common answer, or the mode for both of these groups, for the not a victim and a victim, is low. The highest is 64.2 for the no group and 41.5 for the yes group. So there is no clear diagonal, and the lowest, in fact, for both is in the high group, 9.1% for the no, 20.2% for the yes. Even though there's no diagonal, we can begin to think that there is a relationship between being a victim of crime and level of fear. Specifically, because people who were victims of crime experience more high fear and less low fear. And so what I mean by that is, if you look at the high category, they have almost 10% difference in the high category and a 20% difference on the downside compared to the no group. So there appears to be that there is a difference. Even though there's not a diagonal, you could reasonably say, because people who were victims of crime have a higher percentage in the high fear group by 10% and have a lower percentage in the low fear group by over 20%, you can reasonably believe that your hypothesis, being a victim of crime will lead someone to be more fearful, can be supported in this instance. So let's work a third and final cross tabulation, just so we can work on the analysis and the mechanics of going through it. So let's go to Analyze, Descriptive Statistics, and Crosstabs. So this time, let's ask the research question, are there differences between men and women in their fear of crime? And let's propose a one-tailed or directional hypothesis. And let's say women are more fearful of crime than men. So we have our fear of crime already in the column, so that's where we'll leave it. And we'll just replace the victim variable with a gender variable. And the gender variable is towards the middle. And I want the same statistic, so I want my independent variable gender on the row and my dependent variable fear of crime here. So if I was proposing, I would leave it very simple like that, but since I'm proposing a one-tailed hypothesis as opposed to a two-tailed, I'm going to specify and say women are more fearful. So I've clearly indicated which group in the gender variable and which direction that group goes. Higher levels of fear, which is a finding we see in the literature, that generally women have, for specific kinds of fear, more fear, and for other kinds of fear there appears to be little to no difference. So I want to check my cells, and I want to make sure that I have, since my independent variable is on the rows, I want to see row percentages. I'm going to click continue, then click OK. SPSS generates my output. So notice my independent variable, female and male, are my two rows, and then my three columns for fear. So again, we don't have a clear diagonal. The most common answer for both men and women is low fear. The least common answer for both men and women is high fear. But in this instance, there's very little difference. There's a slight difference, and that slight difference goes to the medium category, and a slight difference for the low category. So when you only see a 2 to 3% difference between categories like this, you're not really looking at strong evidence that there is a difference between men and women and fear of crime based on how it is here. So based on the results found in this table, I would say that there's very little support that women have more fear of crime than men. So in fact, I would accept the null hypothesis here. The null hypothesis being that there is no difference between men and women in fear of crime, and our research hypothesis was a one-tailed hypothesis that women are more fearful of crime. And so even though they're slightly more fearful in the high category, they're less represented in the low category, which also supports the hypothesis women are more fearful of crime. But the percentages just aren't disparate enough. You would really need a greater disparity between these percentages to walk away with support for your hypothesis. So what you're going to do is you're going to accept the null hypothesis as opposed to reject it and say there's just not enough evidence to say that women are more fearful of crime than men.